It sounds impossible. Yet there was a time when the Arctic was not a land of ice and snow, but a green, swampy paradise. So how did the coldest place on Earth become a tropical jungle filled with crocodiles, turtles, giant birds, and palm trees? How is it possible that crocodiles once swam in Arctic rivers and palm trees once swayed, where today there is only ice and endless winter? What kind of world existed millions of years ago that could turn the North Pole into a lush, green jungle filled with life, with temperatures warmer than cities like London or New York today? To understand this astonishing transformation of Earth's climate, we must travel back into the distant past, to a time called the Eocene Epoch, a forgotten chapter in Earth's deep history when the planet was wrapped in a powerful greenhouse climate. During this era, global temperatures were so high that the idea of ice anywhere on Earth would have sounded absurd. The Arctic was not a frozen desert, but a thriving wonderland of forests, rivers, wetlands, and warm coastal seas full of strange and ancient creatures. Fossil evidence from this time shocks scientists even today. Deep beneath the Arctic's rock layers and ice sheets, scientists have found leaf fossils of tropical plants, pollen grains from flowering trees, ancient algae that only grow in warm water, and even preserved insects trapped in pieces of amber, frozen in time for over 50 million years. How can crocodiles, cold-blooded animals that need warm temperatures to survive, possibly live so close to the top of the world? The answer lies in one of the most dramatic climate shifts in Earth's history. During the early Eocene, carbon dioxide levels in the atmosphere were between 1,000 and 1,500 parts per million, more than triple today's amount. Massive volcanic eruptions filled the skies with greenhouse gases, and large amounts of methane were released from the ocean floor in a chain reaction that caused even more warming. As a result, the Earth turned into a giant natural greenhouse with warm temperatures across the entire planet. The continents had not yet moved into their modern positions, and huge ocean currents carried heat from the equator all the way to the poles. Without frozen ice caps to reflect sunlight, the dark surface of the ocean absorbed even more heat, pushing the climate into a feedback loop that kept the poles warm year-round. Imagine looking at a map of the Earth at that time. North America and Europe were closer together than now. Antarctica was still partly connected to other land masses, and the circulation of warm water was not blocked by ice. Instead, it flowed freely toward the polar regions, turning the Arctic into a sort of massive, warm lake. In this strange, hot world, an ancient crocodile called Borealosuchus ruled the rivers of what is today northern Canada and Greenland. This reptile could grow up to 13 feet long, and its presence in the Arctic is one of the most powerful pieces of evidence that the North Pole had a tropical climate, because crocodiles simply cannot survive freezing winters. They need stable, warm temperatures to digest food and stay alive, which means the Arctic summer must have been as warm as Florida or India. But crocodiles weren't the only animals thriving in these polar tropics. Giant turtles with shells more than a meter wide crawled along riverbanks, feeding on aquatic plants and insects. Mammals like the hippo-sized Coryphodon wandered through the forests, grazing on soft vegetation in swamps and wetlands. Predatory or scavenger birds like Gastornis, a massive flightless bird standing 2 meters tall with a powerful beak, stalked the forest floor. Insects filled the air, bees, ants, beetles, pollinating bright blooming flowers that covered the jungle-like landscape of the Arctic, a place we normally think of as lifeless and frozen. The trees that grew there included magnolias, palms, ferns, and swamp plants that looked like they were taken straight out of a tropical rainforest. In fact, Scientists have found fossilized palm leaves on Ellesmere Island, located near the top of Canada, proving that trees we now associate with the tropics once grew just a few hundred miles from the North Pole. If you could stand in the Arctic 56 million years ago, you would feel warm, humid air and hear the buzzing of insects, the calls of birds and the splash of turtles and crocodiles sliding into muddy water. But how long could such a strange paradise last, and what could cause it to disappear? How could such a hot world suddenly turn into the icy poles we know today? The answers would come millions of years later, but Chapter 1 reveals the incredible truth. The Earth is capable of changing far more drastically than most people realize, and climates we think are permanent are actually temporary. The story of crocodiles in the Arctic is not just a strange fact. It is a reminder that Earth's temperature and life zones have shifted dramatically over time, creating worlds almost beyond human imagination. We often think of the North Pole as something eternal, covered in snow and ice. But in reality, it once pulsed with life, heat and mystery, and everything we think we know about climate begins to fall apart when we dig into the fossilized soil and find the remains of tropical forests buried beneath the ice. So before we can understand why the poles became frozen wastelands, we must first understand that they were once thriving ecosystems where crocodiles basked in the sun, turtles swam in warm rivers, and giant birds walked among palm trees. A place so different from today's Arctic that it forces us to question everything we think we know about Earth's climate history. If crocodiles and palm trees once thrived where today we find nothing but snow and silence, then what kind of force was powerful enough to turn the entire planet into a steamy greenhouse? How could the atmosphere have trapped so much heat that even the poles felt like modern-day tropics? The answer lies in a powerful chain of events that started deep within the Earth and erupted into the sky. Volcanic activity on a massive scale, releasing clouds of carbon dioxide and ash that wrapped the planet in a thermal blanket. During the early Eocene, immense volcanic eruptions, especially in areas such as the North Atlantic igneous province, pumped billions of tons of CO2 into the air, creating an atmosphere thick with greenhouse gases that prevented heat from escaping into space. Carbon dioxide levels soared to 4 times higher than today's levels, a staggering 1,000 to 1,500 parts per million, trapping infrared radiation and causing global temperatures to skyrocket. But volcanoes weren't the only culprits. Under the ocean floor were vast ice-like deposits of methane trapped in frozen hydrates. As the oceans warmed slightly, these methane hydrates began to destabilize and release methane, a greenhouse gas many times more powerful than carbon dioxide, into the atmosphere. This sudden release created a feedback loop. More methane caused more warming, which caused more methane to be released, driving the Earth into an unstoppable heating cycle known as the Paleocene-Eocene thermal maximum. This runaway greenhouse effect pushed the Earth into its hot Eocene state, and the heat didn't stay locked at the equator. It was transported across the globe by massive ocean currents that functioned like planetary conveyor belts. The continents then were positioned differently than they are today. Antarctica was still connected to South America and Australia, which prevented the formation of cold polar ocean currents. Without icy barriers to block flow, warm tropical waters circulated freely toward the poles, delivering heat directly to the Arctic and Antarctic. There were no ice caps at this time, so the bright white surfaces we see today did not exist to reflect sunlight. Instead, The darker surfaces of the oceans absorbed solar energy like a giant planetary sponge. This created what climate scientists call a positive feedback loop, where warming created conditions that caused even more warming. The Arctic Ocean became more like a giant warm lake than a frozen sea. Fossils of warm water algae and microorganisms found in sediment cores prove that surface waters once reached 22 degrees Celsius or 72 degrees Fahrenheit, something unimaginable by today's standards. And while the continents drifted slowly across the globe, they blocked or redirected warm currents in new ways, allowing heat to reach latitudes that today remain bitterly cold. But why did these changes last so long? Why didn't the Earth simply cool back down quickly? Because once greenhouse gases saturate the atmosphere and the oceans warm, the entire system takes hundreds of thousands of years to respond, creating incredibly stable warm periods known as greenhouse climates. Earth has cycled between greenhouse and icehouse phases many times, but the Eocene stands out as one of the most extreme. During this time, warm air could rise high into the atmosphere and trap more moisture. Humid air holds more heat than dry air, which is why these polar forests were not just warm but also lush and tropical. Was the sun hotter back then? No. The real cause was the thick, carbon-rich atmosphere that acted like a giant glass ceiling over the world, holding the heat in day and night. With no polar ice to reflect sunlight and no cold water currents to bring down temperatures, the planet's cooling systems were essentially switched off. But while global temperatures were high everywhere, the polar regions changed more dramatically than any other place on Earth. This is because today's poles are extremely sensitive to changes in heat and solar radiation. Once ice begins to melt, the land absorbs more heat. Once oceans lose their reflective ice cover, they absorb sunlight and warm even more. This same phenomenon happened millions of years ago, but in reverse, the poles warmed first and fastest, creating surprising habitats full of life. Dense forests grew where we expect tundra. Flowers bloomed under months-long daylight in summers where we now see only snow. Insects buzzed, mammals grazed, and crocodiles basked in muddy riverbanks under a sun that might stay up for 24 hours a day during the polar summer. Could such conditions happen again? That is a terrifying question scientists are asking today as we watch atmospheric CO2 climb once more. But the Eocene greenhouse built up over millions of years, while our modern warming is happening in mere centuries, a speed the natural world may not survive. In Chapter 2, we see that it wasn't one simple cause, but a combination of volcanic CO2, methane hydrates, shifted continents, open oceans, and a lack of ice that turned the entire world into a sauna. The Earth did not become tropical at the poles overnight, but once the warming began, everything in the planet's climate system amplified it. The Eocene did not just create a warm world, it created a radically different Earth where familiar rules did not apply. And understanding this ancient global heat wave helps us unlock the mystery of how crocodiles once swam in the Arctic and why the planet can shift so far from what we think is normal. The northern forests and crocodiles were not a bizarre accident. They were the logical result of Earth's natural system pushed to its greenhouse extreme. But just as the planet warmed, it also had the potential to cool again, and eventually a dramatic transformation would plunge the world into ice once more. What kind of animals could thrive in a world where the North Pole felt like a humid rainforest, where snow never fell, and where sunlight streamed through lush green canopies for months at a time? Could it be true that crocodiles once roamed the very regions we now call the Arctic Circle, basking on muddy shores beneath magnolia trees and giant ferns? The fossil record gives us an astonishing picture of life during the Eocene polar world. A bizarre and beautiful ecosystem filled with creatures we would never associate with the icy landscapes of the modern world. In the rivers and wetlands of what is now northern Canada and Greenland, a fearsome reptile called Borealosuchus ruled the water. A crocodile-like creature up to 13 feet long, with massive jaw strength and sharp conical teeth that allowed it to hunt fish, birds, and small mammals. The existence of such a cold-blooded predator in the polar regions is one of the clearest pieces of evidence that the Arctic climate must have been warm and stable, not just for a few days, but for millions of years. Alongside these crocodilian giants lived enormous freshwater turtles that measured over 1 meter in diameter, gliding through warm rivers that were surrounded by forests of palm trees and flowering plants. Giant hippo-like mammals called Coryphodon grazed along riverbanks, weighing more than 500 kilograms and browsing on soft vegetation in the shady undergrowth of dense swamps. Meanwhile, small, agile insect-eating mammals, like Leptictidium, darted through the forest floor, their long hind legs and pointed snouts allowing them to hop and weave through fallen leaves as they hunted for beetles and worms beneath the dense canopy of tropical ferns. Birds filled the warm skies, some perched in trees like tropical parrots, others wading through shallow marshes. One of the most striking birds was Gastornis, a flightless monster towering up to 2 meters tall with a massive beak once thought to be used for hunting but now believed to have crushed tough plant material, making it one of the dominant herbivores on the forest floor. Another bird was Protophasia, a wading stalker with long legs like a stork or flamingo, filtering food from shallow wetland waters, proof that these polar regions resembled modern-day river deltas and swamps. Insects were everywhere. Bees pollinated flowering plants, ants created colonies in fallen logs, beetles scattered across the forest floor, and flies buzzed in clouds near slow-moving streams. Perfectly preserved insects trapped in golden amber tell us exactly which species lived here, providing a direct window into this ancient world. These insects helped recycle organic matter and fed the birds and small mammals, forming the foundation of a complex and thriving food chain. The vegetation of this polar world was equally remarkable. Scientists have recovered fossilized palm leaves, magnolia flowers, and fern fronds from sediment cores, revealing forests full of broad, leathery leaves, towering tree trunks, and thick green undergrowth that looked more like the jungles of Southeast Asia than any place near the Arctic today. Imagine walking through a dense forest at the North Pole in this era, hearing the splash of a turtle sliding into a warm pond while a crocodile floats silently nearby, waiting for its next meal. Imagine seeing giant, primitive mammals grazing among palm trees, all under a sky buzzing with bees and dragonflies, with no hint of snow or ice anywhere in sight. Could anyone who lives in today's Arctic, a place of endless, white, freezing winds and barren tundra, ever believe that just 56 million years ago it was a humid Eden? These fossil discoveries challenge everything we assume about climate and geography, proving that Earth can transform its most hostile environments into places of extraordinary life, given the right conditions. Chapter 3 reveals that the tropical poles of the Eocene were not just warm. They were bustling with diversity, from crocodiles and turtles to flightless birds, ancient insects, and massive mammals. This chapter forces us to ask, if such life could exist once at the top of the world, what else is the planet capable of when climate changes reach their extremes?